Alright, we have in front of us a Harman Kardon PM655 integrated amplifier that I picked up on eBay, and it's pretty rough. I have not plugged it in, I have not tried it yet. It supposedly has a channel out, which I'm kind of nervous. I don't want to put any DC on any speakers. So we're going to bring this up carefully on the dim bulb tester and connect it to some load resistors and test it. A couple of things I noticed right away was the knobs are loose. Some of them, this base contour button is pushed in. A lot of these switches don't feel, they kind of feel kind of gritty. I don't know. Just generally is going to need a full overhaul, it looks like. So this is my first Harman Kardon I've ever serviced, so this should be a lot of fun to work with. If we take the cover off, let's see what we got. I can get the cover off. See what I'm sticking on. Okay. And we look down inside, we can see it's a pretty simply built system. On this side here, we basically have the amplifier. There's TO3P transistors they have. Got our capacitors here. It's a dual power supply with a single transformer. So, and you can see here where they have provision for a second transformer. I'm sure some of the higher end models actually had dual transformers as well. So, I haven't tested anything. I don't know, what it's going to do or how it's going to work. I am pretty impressed with the phono stage that's over in here. We'll take a look at that a little bit later. And I guess first things first, let's connect it up to a dummy load into a dim bulb tester and turn it on and see if we get anything out at all. So we'll be right back. Okay, so I have this set up to my dim bulb tester, and we're going to turn it on and just see what happens here. Okay, so far we have a little power LED that's lit up, and sounds like at least, looks like at least it turned on. Looking at the DC offset right here, we can see, let me show you where we're at. On the oscilloscope, I'm running a little bit of negative DC offset. If I turn my speakers off, we can see it goes back to 0 volts. And when I go like that, you can see both channels have some negative DC offset voltage on them. So right there, we're probably going to have to adjust. But of course, I don't have full power on this thing. That could have something to do with it. So I'm not going to worry about that right now. It's it's 200 millivolts, but that's not too terrible. I've also noticed as this thing's been powered up for a little while now, the dim bulb is actually lighting up a little brighter, and to my understanding, the way these amps work is they don't actually have a relay, speaker protect relay. Basically what they do is they bring the system up slowly somehow with transistors or something, and to warm the system up slowly and not to put pop into the speaker when you turn it on. So at least that's what I've heard. We'll get into the schematics a little later here and verify all that. Definitely going to do a recap on this if everything's good. But I think the next thing to do is let's put a signal in here and see what we get, if we get any kind of an output. Okay, so I have a sine wave, 1 kilohertz, going into it at 500 millivolts RMS, and I'm going into the video CD auxiliary input, And let's bring the volume up and see what we get. And as you can see, we're getting a whole lot of nothing. So right there's a problem. Both channels seem to be rather dead. So I'm going to move the input over to the tuner and see if we get anything any different. Okay, so let's take this and see what we get with this one. Oh yeah, so we got one channel. Alright, so let's alright. Okay, so I'm still on my dim bulb. And oh boy, this thing's shorting out like crazy now. You see my bulb? You can see the dim bulb is just going nuts right now. It's just cycling on and off, on and off, on and off. Is that weird or what? And you can see what's going on in the output of this as that's happening. Getting all kind of craziness. So, not good. And it looks like one channel is like over the top. Completely out. So I'm thinking we're having some problems here. So let's bring this back over and see what we get. So I guess we can say that there's definitely something really wrong with this. So we're going to have to go get the schematics printed out and I guess figure out from there what's going on. I don't feel, nothing seems to be hot. Anything like that. None of the components are hot. So definitely at least have power supply problems, maybe have problems with the outputs. It was working on one channel for a little bit. If I turn it back on, see if it resets itself here. And I can't tell. So I guess we got one channel out. Okay, and it's just kind of pulsating a little bit. So yeah, this thing's really bad. So alright, no use in going any further. I guess we're going to print out some schematics and start looking at what all it could be. Okay, I have taken this thing apart. I've taken this thing apart, and the first thing I have noticed here, much to my surprise, is, let me show you something. So you look at this cover and you have 1, 2, 3, 4, 5 buttons in this row here. And when I look here, I have 1, 2, 3, 4. And when we look at the back of the circuit board here, right about here, there's a switch missing, which is why that loudness contour button was mashed in like that. So unfortunately, this looks like an amp that somebody has already tried to work on, which is just going to make things all that more difficult. And wow, I don't even know if I have any of these buttons. I'll have to see if I can go online and find some, but really that's kind of a deal breaker here until we can get get this thing back to original condition. The rest of the system doesn't look all that bad. It doesn't look like too much work has been done on it. We can see the original transistors in here, which I'm definitely going to have to test them. And our driver transistors, I'll have to go through and test them. They most likely one of those could be out, but I also have a feeling that really the main reason that that channel's out is somebody's been messing around with this preamp section over here and have it all messed up so none of the controls are working properly. So we're going to have to pull this preamp board and really give it a once over before we even get to the amplifier portion, because and again, still looking at the power supply and everything as well. But we just have to kind of take this one little step at a time. As you can see, this whole power amp board, I don't see any signs of anybody soldering on this at all. This all looks pretty original to me, and it doesn't look like anybody's been messing with it, but obviously somebody has tried to mess with this. So I think I'm going to pull this, look at what all's been done to it, see if I can find a replacement one of those switches, and take it from there. Okay, so I have it apart, and we can see right in here where that switch has been removed, and somebody has soldered in some jumpers, and so they've tried to bypass that. I also see somebody had the little holder out, that little keeper that holds the switches in. So yeah, obviously somebody has worked on this. So we're going to need to go through every control, every switch, everything, and make sure everything is working properly before we can go any further with this. So I'm going to probably order a switch online if I can find one and try to restore this if I can. If not, I'll have to leave that modification in there. And then I'm going to take all the controls apart, clean them. Might as well recap it while I'm in here. Go over all the little components, test them all, check every switch for continuity, and then reassemble this front end, and we're going to give it another try. Alright, I got this whole thing tore apart, and this is turning out to be real fun. This thing's a basket case, I'll tell you. Okay, so I recapped the top of this thing. If I can get it turned around here. And put the caps in. Took care of what I needed to do up here. Cleaned all these controls. And determined that you cannot find that switch. That switch is rarer than hen's teeth. So it looks like I'm just basically I redid these little jumpers to put it permanently into loudness contour mode. This machine actually has, see if we can get in here, bass contour right there. You can see on the bass contour circuit it actually has a physical circuit, not just a couple of capacitors and resistors. It's actually an active contour circuit. So I wired it into it. I usually leave it on anyways. This is certainly not going to be a machine that's candidate for selling as restored. So I may just keep this one and experiment with it. Maybe I'll do some modifications on it here after I get everything running. So I'm pretty confident I got this put together, and whatever taken care of is repaired. And I'm going to put this front end back together. I'm going to test it and see if it works. Then I'm going to disconnect the this does have a loop through for preamp out and amp in. I'm going to separate those, and I'm going to feed a signal directly into the amplifier section. And I'm also going to look at the output of the preamp section and make sure that kind of narrow everything down, all the problems, and see where we're at there. If that's all working and this is all good and I'm happy with it, I'm going to move on to the amplifier. Let me see here. move on to the amplifier here, and it is really dirty, dusty, messy too. And I'll test all the components and we'll move from there. So that's kind of where we are at the moment, and as soon as I get a little more going on here, I will we'll be back. Okay, I got this all together. I lifted the legs of these transistors, and thankfully they're all good, so that's a great thing. And I got all these put back together. I got the faceplate cleaned up. It looks a lot better now. Put back together, and I'm giving the knobs a little bath in some simple green mixed with hot water, and I'm going to put those on, and then we're going to give it another try. Okay, I got this all put together, hooked back up to the dummy load and to the signal generator. Everything's kind of reassembled here. I tested the transistors; they're all good, like I said. And let's focus in on our scope here and see what happens when I turn this on and bring it up. I'm at 5 volts per division, so I should be able to see some sort of output. And there we go. Look at that. Okay, so far so good. Getting something. Alright. Let's increase our voltage a little bit. Let's see how high up we can go, see if it'll explode. Things just keeps on trucking, doesn't it? Let's see. Let's go some more. Wow. They're finally topping out there. Okay. That is a lot of power. So everything is working now. Now, the only thing I do not know is let's okay, so the tone control is still not perfect. See that the treble was still not right. I think those little switches are bad. However, that's really good. Okay, let's put our voltmeter on and see what kind of wattage we're getting. Let's see here. We might bring this thing back from the grave yet, in spite of everybody that's worked on it. So let's see what our RMS voltage is. Connect this up. Just going on one channel. Alright, let's see what we get. Take it all the way up to clipping. About there is where it's clipping. 22.7. Say 22.5, let's call it. Alright, so let's do our math. $63.3 watts, and this is a 60-watt generator, 60-watt amplifier. So it's performing admirably. Now we got to deal with all the mess. As you can see, the dirt on the capacitors, the board's all filthy cruddy. But we'll clean that up, and we're going to recap it. Still got a little bit of work to do on the tone control circuit. And this is not doing bad. So put a little bit of power to it for a little bit and see how this heats up. No heat at all. I'm at just about full power, and not even getting warm. I haven't even messed around with the DC balance or bias or anything. So I'm sure they're pretty close, but we will definitely go over it. But I think this machine's going to be usable, and other than the base contour, I think we'll be okay. So that's all good news. So let's get to work on this amplifier board, and we'll do some more testing. Alright, so I got all this put together now, and turned out to be a little bit more difficult than anticipated. We got the board, the front preamp all back together and tested, and when I first tested it, it didn't work. One of the channels was out again. So what I ended up finding out is all over the inside of this amp you have these little ribbon cables to connect the signals from the different boards, and the one coming from the main volume pot, see if I can get this up here where you can see it right here, this little one down here, you can see where it solders on there. The solder joint was cracked, and that kind of led me down a little side path on this amp restoration, and I found that a lot of the solder joints on this were not very good. I don't know how they've mass produced these or anything, but what I found was there was a lot of areas where the solder didn't catch the board properly. They made like little solder balls. I don't know if they didn't use the right flux, but I had to kind of go through and touch all these up, and I was finally able to get everything back to work properly. And then I moved on to the main amp board, and I recapped all of that. A little note on capacitors: I know there's a lot of controversy about recapping a amp, just wholesale replacing all the capacitors. And my thought process on this is, if you're in here, if the cost of the capacitors is not worth more than the amp's going to be worth when you're done, you should do it. And the reason I say that is, even if each capacitor is individually good, but has a small amount of leakage because of its age, that leakage adds up. And I've already proven this on other amps that I've done, where I've done a Pioneer SX750. None of the capacitors really seemed individually bad. They just had a little bit of leakage, nothing more than you would expect on an older capacitor. But the voltage regulator was getting just really hot, and I couldn't figure it out for the longest time. I mean, all my voltages were what they were supposed to be. The current in different areas all looked good. Everything looked like it should, but the transistors kept getting hot. I tried replacing the transistors. I tried new heatsink grease, bigger heatsink, all these different things. It just wouldn't stop. It just kept getting too hot. So finally I went through and I recapped the whole amp. And I recapped the tuner circuit. Anything with electrolytics got replaced. And lo and behold, when I turned the machine on and we tested it out, I came to find that all of a sudden that transistor was not overheating. The voltage regulator was not getting too hot. So basically what I'm saying is, all these little capacitors in here, all the leakages will add up. And even though the amp will function properly and it will sound good, your power supply is being forced to produce more current than it was designed for. So it may not be way too much current that will burn anything up, but it's going to make your voltage regulators and your rectifiers and so forth run hotter, which is going to cause them to wear out sooner. So recapping the amp fixed that. Okay, so that's my thoughts on this. And like I said, you can see there are a few caps in here, but maybe $20 worth of caps, $25 worth for an amp that's probably, these are good amps. I think this would be worth way more than $20. So the other thing is, I just had a couple of these main filters. The old ones were good and they didn't have any leakage. They were actually really good, but I upsized these a little bit. They're this is matched, but they're two different versions of Nichicon. They're both high-end capacitors. They're good. So not going to affect anything. These aren't in the audio path. These are your main filters. I went from a 4700 to a 6800 microfarad. I didn't go too over crazy with it, but a little more power reserve. This amp is wonderful at even clear down to 10 hertz. I get almost no distortion at rated power. So I'll turn this thing on here. We'll turn on the scope, and we're going to take a look at how this thing performs now that we got everything all taken care of. I do have a new piece of test equipment. If you can see up here, let me zoom in on it. Right here. And I don't know if you can see that. It's a Keithley 2015, and the interesting thing, there's two things about this I really love, and I've been looking for one for a good price for a long time. And it is, number one, it's very high accuracy. It can do the 4-wire ohms reading, so you can do 4-wire and 2-wire. So, with the sense wire, Kelvin as they call it. It's got a lot of digits. I think it's a 5.5 or 6.5 digit. And the other really cool thing that I've never seen before on any other meter is it can do total harmonic distortion. So on the back there's a little signal generator. It puts out, I think, a 1 kilohertz tone. You can come out of that. I got a little cable here going back to it. Plug it into your amp and loop it through to your input here, and you can actually measure the total harmonic distortion. So I'm still playing around with it, getting used to how it all works. So when I get a little better, maybe the next amp that we do, we'll try to use this to actually physically measure the total harmonic distortion. I've always wanted a distortion meter, just because it would be neat to be able to put a quantitative number to the distortion at rated power. But they take up a lot of bench space, which, as you can see, I don't have, and they're expensive for the one function that they perform. The other thing I've noticed is you can see it on the scope. If if you're dialed into your oscilloscope, you can see when it starts distorting. Of course, I can't see the difference between 0.01 and 0.05% distortion, but really, can your ears hear that? I know mine can't. And of course, when you get up into your 40s and 50s, like a lot of us are now, your hearing isn't perfect anymore anyways. You're not going to hear some of the things that you could have heard when you were in your 20s. But anyhow, I'm showing my age. So anyhow, let's fire this all up, and let's see what we get. Hopefully this thing will be working for us. Turn on my signal. I'm going to put a 400 hertz tone on this, and then we're on the amplifier, or on the screen here of my scope. And if you see, I'm at 20 volts per division. Going into the dummy load. Let's see if we can get this guy into the picture as well. We'll look at our RMS voltage on one channel. Let's bring it up till we get some. Right there, it's starting to clip, and you can see the one channel goes into clipping a little bit before the other. Not much, but tiny little bit of imbalance. And that could be that the transistors aren't perfectly matched. And when I did the test on these, the gain on them was a little bit different on the one side. The transistors, they were not perfectly matched. But still, until you get to rated power, you don't really notice it. So let's call it right there, 23.4 volts AC RMS. Turn that down so I don't fry my resistor. Okay, so we're going to take our, let's see here, 23.4 times 23.4. It would be nice if I had a calculator that would do squares and stuff. Divided by 8 ohms, 68.445 watts. So this is a 60 watt amplifier. I'm getting 68 watts now. just so you know, before I did this little test, before I put the new main filters and recapped the amplifier, and it was a little more unsymmetrical between the channels, and it was breaking up a little bit sooner because of the smaller capacitors and so forth. I was still getting rated power, but it was just barely getting right up to about 60 watts. So we gained another 6 watts. Now what does that mean in volume? Not a whole lot. It's diminishing returns as you turn, as you go up in watts in an amplifier, it's diminishing returns. So a 100-watt amplifier isn't necessarily going to be double the volume, the loudness to your ears as a 50-watt amp. It's just kind of the way it works. So hope you enjoyed this little video. It wasn't really a complicated one. The biggest issue with this amp was really dirty, needed cleaning. Other people had worked on it before, so there was kind of some messes in there from that we had to clean up, and needed recapped. And the bass contour switch is those tiny little switches made out of unobtainium. Unfortunately, we can't get those anymore. I permanently wired the bass contour on. These amps are known for that circuit. I probably wouldn't want to turn it off anyways. You're not going to be a purist if you listen to this amplifier. It's going to taint the sound a little bit because of that bass contour circuit that's always on. But again, my ears aren't what they used to be. I mess around with the tone controls anyways. I don't have the perfect listening place. So I'm not against adjusting the tone to make it sound good to your ears. So anyhow, that's about all we have for this amp. The other thing maybe I'll talk about real quick before I cut this is, let me pull this back. Something interesting about these amps, shut this off. If we look, let me get this out of the way here. This protection circuit right here, you can kind of see it. It's a little different. If you notice, there are no relays on your power supply on this amp. Okay, so here's your power supply, very basic. Basically all we're doing is you have two windings with, one winding with a center tap, I should say. And instead, this is kind of a poor man's dual power supply. On the older ones, the old HK twins, like the 730s and so forth, I think they are, they actually had two separate transformers. So you would have one going here, and then you'd have another transformer feeding this one. This one, they just put a larger transformer, and then they just came off with two sets of bridge rectifiers, two sets of capacitors. It's kind of a semi-isolated power supply, but really at the end of the day, I think it probably would have been better off to use just a larger rectifier and larger filter capacitors, kind of like Pioneer, Sansui, Kenwood, all those guys do, unless you're going to use two separate transformers. But, I think it was a gimmick for the high current thing that they talk about. Regulation right here, very simple voltage regulations. Linear power supply, you have your transistor, and your bases are controlled by this Zener diode, and you get your fixed 15 volts and 24 volts, negative 15 and negative 23.4 right there. Very simple to troubleshoot. And up here, instead of having a relay circuit, and this is what I was saying is interesting, is this protection circuit kind of monitors everything up here, and it does kind of slowly bring up, slowly electronically, but bring this up. You don't hear any pop in the speaker when you turn it on, and very, very actively measures the rails, the power rails. And when I was running this on a dim bulb tester, when I started drawing some current, this circuit actually would crowbar down and then try to come back up to test and see if it knew that there was something going wrong with the voltage. It was very actively protecting the circuit, whereas on you know, on your traditional, like your Pioneers and Kenwoods and whatnot, you would have had a relay. It sensed, you know, when it sensed something wrong, it would just shut down. It would wait a couple seconds and it would click it back on, you know, and then it would wait a couple seconds and click. This thing here was really rapidly controlling things. So interesting circuit. You can see the FETs that they put in the MOSFETs they put in the front here, and you know, and you could see it's tacked right onto your DC. It's a neat little circuit. I'm going to go through this one of these days and just kind of figure out the whole thing. Unfortunately, there's no theory of operation in this service manual that came with this. So I'm going to have to sit down and trace everything out to figure it out. But it's interesting enough that I may want to do that sometime. But I can definitely say it works. It works well. So that's about it. And I'm going to wrap this one up and call this one finished. And I have a whole ton of things ready to go on the bench. I have a cassette deck, a pretty nice one, an old one from the 80s I'm going to do. I'm going to go over. I have a Pioneer SX another 750 I have to do. I have a 450 SX Pioneer that I have to do. I have a Pioneer SA 65 or 8500, which is the big brother to the 7500 we did. I have quite a bit of things that I want to work on. I probably have to take my 2465 scope down and look at that pretty soon, because I'm getting an error when it boots up on the counter timer circuit. So I've never played with that before on that, so that'll be a little bit of a learning experience. So lots of projects coming up, lots of things going on, and just depends on how busy work ends up being as to when I get to all this. But if you're watching this, thanks for coming here and watching and working on this with me, and give me a thumbs up, and hopefully we can grow the YouTube site a little more and continue on. Have a great day. Thanks.